Today we're going to continue our study in angles. In particular, we're going to talk about different types of angle pairs that have certain relationships with each other. So first, let's talk about some types of angle pairs. So complementary angles have a sum of 90 degrees, and we would say that each angle is the complement of the other. So let's say you have a 20-degree angle and a 70-degree angle. We would say those two are complementary angles. You would also say that the 20-degree angle is the complement of the 70-degree angle. Next, we have supplementary angles, and those have a sum of 180 degrees, and we would say each angle is the supplement of the other. So you could say that a 100-degree and an 80-degree angles, a 100-degree and an 80-degree angle, are supplementary angles. You could also say that the 100-degree angle is the supplement of the 80-degree angle. Next, we have what we call adjacent angles, and these are two angles that share a common vertex and side, but they have no common interior points. Okay, so here we have some examples. On the left here, we have complementary angles, so angles that will sum up to 90 degrees. And you can see that the one on the left, those are adjacent complementary angles. So you can see how they form a 90-degree angle. You can see that they sum up to 90 degrees. But in the second one, we have non-adjacent angles. So you can see here that they don't share a common vertex or a side, but they still sum up to 90 degrees. So they are still complementary angles. On the right there, we have supplementary angles. And you can see here that angles 5 and 6, they are adjacent to each other. They share a common vertex and a side, although they have no common interior points, so they are adjacent to each other. And they are supplementary angles because they have a sum of 180 degrees. And on the far right there, angles 7 and 8, we know those are non-adjacent because they do not share a common vertex or side. But we still know that angle 7 and angle 8 will still sum up to 180 degrees, so we know that they are still supplementary angles. All right, example 1, identify complements and supplements. So in the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. Okay, so we need to find two of these angles that are going to add to 90 degrees, and that will give us the complementary angles. So definitely not the 122 because it's already more than 90 degrees. So try the 32 and the 58. So because the 32 and the 58 add to 90 degrees, we can say that angle BAC and angle RST are complementary angles. Now to find the supplementary angles, we're trying to find two angles that will add to 180 degrees. Now we can see here that the 122 and the 32 will not add up to 180 degrees, but the 122 and the 58 will add up to 180 degrees, so we can say that angle CAD and RST are supplementary angles. Lastly, we have to identify a pair of adjacent angles, so we can see here that we have two angles that share a common vertex at A and a common side, that's the AC ray. So we would say that angle BAC and angle CAD are adjacent angles. All right, example 2, find measures of a complement and supplement. So given that angle 1 is a complement of angle 2, and the measure of angle 1 is equal to 68 degrees, find the measure of angle 2. Okay, so since angle 1 is a complement of angle 2, we know those two have to add up to 90 degrees. So if you want to, you can absolutely draw a diagram for yourself. But really all you need to do is 90 minus 68 to find out what we need in order to get those two angles to add up to 90. So this is going to be 22 degrees. So 68 plus 22 gives us 90 degrees, so the measure of angle 2 must be 22 degrees. Okay, part B. Given that angle 3 is a supplement of angle 4, and the measure of angle 4 is equal to 56 degrees, find the measure of angle 3. Now we can do something similar here, and we can draw ourselves a diagram. But remember that in order for two angles to be supplementary, they must add up to 180 degrees. So all we need to do here is 180 minus 56, which gives us 124 degrees. So angle 3 is going to equal 124 degrees. Example 3. Let's find some angle measures. When viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measure of angle BCE and the measure of angle ECD. Alright, so step 1, we'll use the fact that the sum of the measures of supplementary angles is 180 degrees. And then since it's not asking us to solve for x, we're going to have to use what we found for x and substitute back in to find the measure of angles BCE and ECD. Alright, so let's start with the fact that those two angles have to add up to 180 degrees. So 4x plus 8 and x plus 2 should add up to 180. So the measure of angle BCE plus the measure of angle ECD equals 180. We'll substitute that. We'll try to simplify as much as we can. So now we have 5x plus 10 equals 180. Subtract the 10 from both sides, so 5x equals 170. And divide both sides by 5, and we get x is equal to 34. Alright, next we are going to evaluate using x equals 34. So to find the measure of angle BCE, which we know was 4x plus 8, we substitute 4x plus 8. So we have 4 times 34 plus 8, which is equal to 144. We'll do the same thing with the measure of angle ECD, which was x plus 2. So substitute that x in with 34, so we have 34 plus 2, which is equal to 36 degrees. So the measure of angle BCE is 144, and the measure of angle ECD is 36 degrees. Okay, we have a couple more angle pairs to go over. The first is what we call a linear pair. So we say that two adjacent angles are a linear pair if their non-common sides are opposite rays. And if that's the case, we can say that the angles in a linear pair are supplementary as well. So here is a picture, angles 3 and 4. We would say they are a linear pair. Their non-common sides are opposite rays. They form a line, hence the name linear pair. Since they are a linear pair, that means that angle 3 and angle 4 have to add up to 180 degrees, so we can say they are supplementary. Alright, the last type of angle we'll go over today are vertical angles. So we say that two angles are vertical angles if their sides form two pairs of opposite rays. So if you have basically two straight lines going through each other, then here, for example, angle 1 and angle 3 are vertical angles. You can think of them as being opposite each other, but by definition, it's when their sides form two pairs of opposite rays. And so we can see that in angle 1, one of those sides is a ray that is opposite one of the rays of angle 3. Same with angles 2 and 4. So angles 2 and 4 are also vertical angles because their sides also form two pairs of opposite rays. Okay, we have one last example today. So two angles form a linear pair. The measure of one angle is 5 times the measure of the other. Find the measure of each angle. All right, so we are told that the two angles form a linear pair, so I'm going to go ahead and draw that out. We're also told that the measure of one angle is 5 times the measure of the other. Since we don't know the actual angle measures, we'll call one x and the other one 5x. Now, to find the measure of each angle, we'll first use the fact that these two angles are supplementary, right? Because any linear pairs are going to be, a linear pair is going to be supplementary. So we have x plus 5x equals 180. Simplify that, we have 6x equals 180, and divide both sides by 6. So x equals 30. So we know that one angle measure is 30 degrees, and the other one is going to be 5 times 30 degrees, and so that is 150 degrees. So 30-degree angle and a 150-degree angle, they form a linear pair, they add up to 180, and one of them is 5 times the measure of the other.